So I've kind of been wanting to order these for a while. So I just did it. This is a box of magnetic space filling atomic models called Snatoms. Yeah, in case you're wondering what's kicking around in the background, this is my kid's artwork. This is monarch butterfly area. Anyway, okay. So I went ahead and I bought the big set. I forget what the name of it is. It's deluxe or advanced or something. It's heavier than I expected it to be. I kind of collect models. Like, I enjoy having them, so check it out. Alright, comes with a kit, so everything that's in there. Alright, so this says expansion kit, so maybe that's what I got. I ordered it like 10 days ago. That box completely comes apart. Oh, keep it. It's kind of, as soon as I pulled them out, it kind of opened up. So, alrighty. So we have our double bonds. We've got things connected to each. Oh, okay. These are stronger than I anticipated. And what's really cool is if you watch the Snatums ads. Okay. So this is what this was. The Snatums X. So I think it's the original set plus the expansion pack, but I'm not sure. I'll have to double check. But one of the major differences, one of the reasons I wanted to get this one, is there's a modification to these. Firstly, so my husband's also a chemistry person. He has a PhD in chemistry and a bachelor's in chemistry. And whenever we would watch the videos about these, we just said there's got to be a problem with the way the magnets are oriented in these, and that they have to be in there so that there's a polarity issue, you know, so that some of them would click some of the time. How do they deal with that? Here's what they did. It's a spherical magnet. So with a spherical magnet, can you hear it? It can turn in there. So any of them can connect to any other ones, which is a really clever solution to that, I think. This is in a tray. It's got 3 things, and they're stuck together. I was expecting this to have latches on the side, but it's really kind of just a tension sort of system. I could put them in a different order, which is nice. The one on the bottom still has the clips on it, so if I wanted to put them in a different arrangement, I could. And these are pretty strong. So we've got 2 carbon, and I have the magnets exposed, and so with the magnets exposed, I can hold more weight. And I know that from watching videos of these, that allows them to hold more tightly than if there was plastic across there. Let's see how long of a chain I can make. So there's 2 carbon, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. 14, 15, 19. Oh, these only have 1. It's just a look. Here we go. Good job. Oxygen. There we go. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. I had 26 of them in a chain. And I think it only broke because I tried to stop. The sounds are really satisfying on these. All right, so let's see. I think the only thing that has to happen is this little tray has to go on the top because there's no space in it for it to go this way. Ooh. All right. Check this out. It has some examples in here of different things that you can do. All right. They actually have examples here for carbon nanotube and Buckminster Fullerene, but it says it requires more than one kit. So a Buckyball is C20. Yeah, you definitely would. So one question that I had is, well, maybe I can use other elements for that. But you can't because these have different, yeah. Okay, these are pretty good. So they've set these up in a way that you can't, like I couldn't substitute, they just pick up each other. You couldn't substitute different ones. So nitrogen here only has the capacity to do 3 bonds. That's fine. You wouldn't be able to model that extra electron pair with these. These can make 4. Then we have, let's see, what do they call them? All right, so our sheet says that we've got 2 different forms of sulfur and 2 forms of phosphorus. So honestly, I'm kind of getting a kick out of the noise. So the forms of sulfur would be a 2-sided and a 6-sided form. So this one, probably more for basic chemistry and organic chemistry. There's some little plastic tabby doos on here. Okay, so these can make 2 bonds. These can make 6 bonds. So we've got, I mean, this is capable of doing like an isometric thing. It's interesting because this could actually allow you to make mineral structures, potentially. So we've got 2 forms of sulfur there. We've got 2 forms, it says 2 forms of phosphorus. That's our pink and our purple. The purple phosphorus has the capacity to do 3 bonds. So there's 3 bonds on one side and none on the other. The pink one can do 5. So this is your classic one. We've got 1 on either pole and then 3 around the middle. This is actually quite flexible. Here's some larger ones. They've got this marked as ionically bonded bromine, but it lists all the halogens, and so it has a bunch of color codes, but it also lists alternate elements. So those would be elements that behave similarly in terms of the way that they make bonds and form molecules. We've also got some examples in here of single bonded, double bonded, and then what it says is complex things. And these are the ones that we've seen before: glucose, cyclohexane, the nanotubes that we can't build. It's also possible to do a whole bunch of different geometries. So what's really nice, one of the things that I was kind of unsatisfied with the space filling models where you had to plug the pieces together was you couldn't you couldn't build really complex things. What's nice about this is it's a space filling model system, so you get a sense of the way that space is taking up and moving around. So let's see. I've seen those models too that are magnetic sets of water. So I'm looking at one of my hydrogens because it's got like that's embedded in the plastic. I don't think that's coming off. I'm gonna ask if there's a way to clean it so I can make water. That's fun. I don't. Yeah, these can't interact with each other. I ordered micro Snatoms too, so maybe those will be different. Check out my hydrogens. Maybe it's harder if they're white. Okay, so there's our oxygen with some hydrogens attached to it. Yeah, so manufacturing wise, I'm picking up some plastics and stuff. I'm not sure what that's about. I don't think it matters that much though. It's interesting because you can see through them, so you can see where, I don't know, these must be points where they holds the atom together. So that might help you get a sense for that shape a little bit better. And our phosphorus. This one only can hold 3. So much easier than the ones with sticks. This one's got 5 attached to it. There we go. I always like the orientation where you have a pole and then 3 around the pole. So it's pretty cool. I've got a whole collection of them down here. So you can get a bunch of different geometries. And these are pretty, you know, you can build these and be able to compare them and what's similar and different about them. All right. These guys are awesome too, bromine. Try to knock it off. Honestly, I expected it to pop off already, and it hasn't. There we go. Not too bad. Now, at school where I teach, I have a magnetic whiteboard. So I think that there's some potential that I could also stick this onto the board. I'm not sure if that's a great teaching idea though, because once you attach them to the board, you're actually forming a bond with your model with the board, and that would change the way that you can show students that. So I don't know if that method is really for me. I don't know, these are pretty fun. I think I'm gonna enjoy messing around with these. All right, so here's what I will say. I am planning, just having them in my hand, they're all sticking to each other. I am planning to create some things about helping students to understand different kinds of models and being able to understand spatial relationships. Sorry. So I work with high school kids, And with high school students, one of the things that can be a struggle for kids, especially at the high school level, especially when they're dealing with chemistry for the first time, is being able to form an accurate mental model of what's happening when atoms are forming bonds with each other. And what does that mean for the way that they take up space? We show kids Lewis dot structures. We show kids ball and stick models. We sometimes give them the models that are the plastic balls with little rubber sticks between them. I've always kind of wanted something that's more space filling and that's easier to use, because I think that for some students, this is going to help a lot with helping them to understand that the way that molecules take up space really impacts the way that they behave, especially in biological systems. And so, and also stereochemistry. And so I'm hoping that these will be able to help students with that. So what I want to know from you guys, from the audience, is do you guys have specific questions about this particular product? Or is there something that you want to see compared to this? So do you notice that there's different problems that students have with spatial reasoning or understanding different models of the way that we draw structures for chemistry? Because that's on the schedule for things I want to film. So I think these are really great. I'm happy I got them. This set, I paid out of pocket for it. It wasn't something that was donated to me. It was $100. I ordered them a week and a day ago. That's how long it took them to get to me. I don't know if that's because of slowdowns at the post office or not, but I mean, it's kind of reasonable. It's a reasonable amount of time for a not Amazon purchase, I think. Yeah, I'm pretty okay with this. I feel like this is really basic. You know, in terms of $100 model set, it would be nice to see this with a little bit more information, but because I'm a teacher, I feel like I can fill that in pretty well for my students. So if you're thinking about buying this because you're a student yourself, and you're working in a situation where you need to understand either stereochemistry or space filling or relationships of atoms between things, you know, go for it. If you're buying this so that a child can use it and play with it, firstly, be careful because it has small magnets. And so if you have a kid who's going to pop these open, the magnets may become a problem, or the pieces may become a choking hazard. But there's not a lot of science content in the paperwork that came with these. So you're going to probably want to supplement that with other things. Otherwise, you're just playing with a really expensive magnet set. You know, you might want to go magnetiles instead. Like that's a really cool toy. Anyway, I'll get off my soapbox about that. So I think that they're cool. You know, the only downside is I have got one piece that's got like manufacturing skulls on it, and I'll just call them and check with them about it. But it's a great kit. It's got a nice box. It's not a cardboard box, and it snaps closed. I have so many model sets. It's just got a tray lid that sits on top. You walk around with it. If you drop it, those pieces are all going to go flying. These are very happy to stick to each other. You know, dump this out. They're all stuck to each other. That's how easy this is. All right. I'm going to sign off. This is Chrissy O'Malley for Better Science Teaching, and I hope you enjoyed our Snatoms unboxing. I'll talk to you soon.